Before the universe as we know it had a chance to expand and create space and time, there was something else, an unimaginable realm that existed beyond our grasp. Imagine a state where the very fabric of reality was unformed, yet packed with infinite potential, hinting at origins even older than the Big Bang itself. This is the story of the Singularity Before Time, a voyage into the mysterious depths of what came before everything, revealing secrets that could redefine our understanding of existence itself. Stay tuned, because what lies beyond the beginning might just hold the key to understanding the very nature of reality. The concept of the singularity before time. Before the commonly accepted moment of the Big Bang, the idea of a singularity pushes the boundaries of both physics and philosophy. In conventional cosmology, the singularity is often depicted as an infinitely dense point where space, time, and known physical laws break down. But what existed before this event? Physicists have long grappled with this question, and while current theories remain speculative, some frameworks suggest that the concept of a singularity might have roots that extend beyond the conventional boundaries of time itself. Before the universe as we understand it came into existence, some models propose a state where traditional notions of causality and temporality lose meaning. For example, in certain interpretations of quantum gravity, the singularity is not necessarily a point in space and time, but might be better described as a domain where space-time simply ceases to have its usual properties. In this view, asking what existed before the Big Bang becomes a nonsensical inquiry, akin to asking what's north of the North Pole. Instead, the focus shifts towards mathematical descriptions and conditions that lack a clear temporal ordering, hinting at a pre-physical realm or a different dimension within which the concepts of before and after are irrelevant. From a theoretical standpoint, the idea that something existed prior to the singularity involves the notion of a pre-Big Bang phase or universe. Certain cyclic models, for instance, hypothesize an eternal oscillation of universes, each Big Bang giving way to a contraction or a rebirth of space-time. These scenarios suggest that the singularity isn't an absolute beginning, but rather a transitional phase, a point of transformation rather than creation. In such models, the concept of what existed becomes intertwined with complex ideas about the multiverse or higher dimensions where our familiar universe is just one chapter in an ongoing cosmic story. The challenge lies in formulating testable predictions that can either support or refute these ideas. The philosophical implications are profound. If the singularity is a boundary where time itself originates, then imagining what existed before naturally becomes a question that transcends physics, veering into metaphysics and existential inquiry. Some theorists posit that the singularity may be a boundary condition or a limit of human understanding, an ultimate horizon rather than a starting point. The possibility that the universe emerged from a form of cosmic nothingness, or from a state that defies our spatial and temporal intuitions continues to inspire scientists and philosophers alike. Unraveling these mysteries might require scientific breakthroughs that extend beyond conventional theories, opening pathways into the unknown domains of quantum spacetime, and perhaps even requires rethinking what it means for something to exist at all. Theoretical foundations and cosmological models. Before the Big Bang, modern physics reaches into realms of speculation that challenge the very notion of before. Conventional cosmological models are rooted in Einstein's general relativity, which describes how space-time curves and evolves. Yet, these models hit a breakdown at the singularity, the point where density and curvature become infinite. Some theorists propose that prior to this moment, the universe might have existed in a different state, governed by alternate physical laws or higher dimensional constructs. These ideas are often built on the foundations of quantum gravity, attempting to reconcile the principles of quantum mechanics with those of general relativity, though a complete, experimentally validated theory remains elusive. Several models explore the concept of a universe emerging from something akin to a quantum foam, a chaotic, fluctuating fabric of spacetime at vastly smaller scales than can be directly observed. In these frameworks, the singularity might not be a true point of infinite density, but rather a transitional phase, perhaps a bounce from a previous contracting universe or a state where classical notions of space and time cease to apply. Loop quantum cosmology, for example, suggests that space-time itself has a discrete structure, setting a minimum scale and potentially eliminating the singularity altogether. This produces scenarios where the universe undergoes cyclic phases, expanding, contracting, and rebounding, challenging the idea of a singular origin story. Cosmologists also consider the multiverse paradigm, which posits that our universe is one bubble within a vast and possibly infinite multiversal landscape. In this context, the before of the Big Bang might involve a much larger cosmic ecosystem, where different universes continually nucleate, collide, or collapse. String theory offers another approach. Dimensions beyond the familiar four could have played a role in shaping initial conditions. The idea of branes, multidimensional objects on which our universe resides, leads to hypotheses that our Big Bang could have been the result of a collision between these branes, implying that before might not be a singular event, but a phase within a more extended multidimensional stage. At the heart of these models lies the challenge of testing their validity. Since these conditions occurred at energy scales far beyond current experimental reach, scientists rely heavily on mathematical consistency, indirect observations, and the quest for observable signatures, like specific patterns in the cosmic microwave background or gravitational waves, that could lend support to certain hypotheses. The exploration of what existed before the traditional Big Bang pushes us into the realm of pure theory, blending the frontiers of physics with philosophical inquiry, all while grappling with the limits of human comprehension of the universe's deepest origins. Possible states of the pre-Big Bang era. Long before the universe expanded into the vast cosmos we observe today, theorists speculate about a realm where conventional notions of space and time break down entirely. One idea considers the existence of a pre-Big Bang state, an era that defies our current understanding, yet offers fascinating possibilities about what might have been. In certain models, the universe didn't simply spring into existence from nothing. Instead, it transitioned through various potential conditions, each with unique properties. In some proposals, the universe existed as a quantum fluctuation, a fleeting, unstable presence within a larger, perhaps infinite, quantum field. This state might have persisted in a sort of vacuum, with fluctuating energy levels that eventually triggered the Big Bang. Alternatively, some theories entertain a cosmic bounce, where a previous contraction phase culminated in a dense, highly energetic state that then expanded outward. Under these scenarios, the universe wasn't born from an absolute beginning but emerged from a cycle, a rebirth of sorts, challenging the linear narrative most are accustomed to. Another speculative realm involves different configurations of dimensions higher than the familiar three of space and one of time. These extra dimensions, predicted by string theory, could have existed in various energetic states, compactified or extended in ways that influence how the universe transitions into our current reality. In such conditions, the pre-Big Bang universe might have been a complex and dynamic interplay of multidimensional spaces, an intricate ballet of forces that culminated in a singular, transformative event. Thinking about the possible states of this pre-Big Bang environment also brings into focus concepts like the multiverse or parallel universes, where multiple, diverse states could coexist or follow different evolutionary paths. Some models propose that our universe is just one bubble amid countless others, each with its own set of physical laws and initial conditions. These ideas open up the notion that what preceded our universe might not be a singular state at all, but a sprawling, interconnected landscape of possibilities, an intricate web woven from the raw fabric of physics itself. Implications for understanding the origin of the universe. Before the Big Bang, conventional physics reaches a boundary where our understanding begins to fray. The notion of a singularity, often described as an infinitely dense point, challenges our ideas about causality and the fabric of spacetime. Some theories propose that prior to this event, the universe existed in a state that defies normal comprehension, a realm where familiar laws of physics no longer hold. This opens up possibilities that the universe might not have a definitive beginning in the traditional sense, but could have been part of a larger, more complex structure or process outside of our standard models. Exploring the concept of the singularity before time extends into the realm of quantum gravity, where classical descriptions of spacetime are replaced by probabilistic and quantum-based frameworks. If spacetime itself emerged from a quantum fluctuation or a multiversal interaction, then asking what happened before the Big Bang becomes a question that may lack a meaningful answer within the confines of traditional physics. Instead, it pushes us toward new ideas like cyclical universes or eternal inflation, where each Big Bang might be just one phase in an ongoing cycle or a vast multiverse with no clear starting point. This perspective has profound implications for how we interpret the origin of the universe. If the universe's birth was simply a transition rather than a creation ex nihilo, it suggests our universe might be a phase within a broader cosmic network, where boundaries and origins are not as discrete as they appear. These considerations can lead to a re-evaluation of concepts such as entropy, initial conditions, and the arrow of time itself. For instance, if there was no before in the conventional sense, then the very fabric of causality and temporal flow need to be re-examined, potentially transforming the way we understand ultimate origins altogether. In practical terms, technological advances in cosmology, like quantum telescopes or particle accelerators, are beginning to edge closer to answering some of these questions. They could provide clues about the nature of space-time at extremely small scales, potentially revealing signatures of pre-Big Bang phases or quantum gravitational effects. Whether or not we will ever fully understand what preceded the Big Bang remains uncertain, but contemplating this singularity before time expands the horizon of cosmological inquiry, urging us to consider a universe that is perhaps part of a larger, interconnected cascade of phenomena far beyond the limits of current science. Usnovnoy, Razgil 5. Before the Big Bang, theoretical frameworks suggest that the universe existed in a state vastly different from what we observe today. Some models propose that prior to the singularity, often described as a point of infinite density and curvature, the fabric of space-time might have been governed by entirely different physical laws or conditions. In these speculative realms, notions like time and space could have been intertwined or even non-existent in the way we understand them now. This sets the stage for profound questions about what existence means before the moment of the universe's rapid expansion. The concept of the universe existing before the Big Bang challenges our understanding of causality and the origins of temporal dimensions. Certain theories, like the cyclic universe hypothesis or quantum cosmology models, posit that our universe could be part of an endless series of expansions and contractions. In such models, the singularity acts more as a transitional phase rather than a true beginning in the classical sense. These ideas open the door to a universe that has no definitive start, but rather a continuous or oscillating existence across different states of spacetime. A key example is the theory of the ekparodic universe, where colliding branes in higher dimensional space initiate the birth of our observable universe. Some physicists contemplate that at the highest energies and densities, the familiar notions of space and time break down entirely. Instead of smooth continua, the universe might have been a quantum foam, a turbulent, probabilistic landscape where particles and spacetime itself fluctuated chaotically. This realm could have been governed by a unified field or an as-yet unknown mechanism that predates classical physics. In this context, the universe's before is not a simple chronological predecessor, but a fundamentally different state that defies current scientific description, possibly requiring a theory of quantum gravity to fully comprehend. Examples from ongoing research include loop quantum gravity and string theory, which aim to provide a cohesive picture of pre-Big Bang conditions. Loop quantum cosmology, for instance, suggests that the universe underwent a big bounce, rebounding from a prior contracting state rather than emerging from nothing. Meanwhile, string theory's multiverse concept hints at a vast landscape of universes, where our universe is just one bubble among countless others that exist in higher dimensional space. These concepts, while still speculative, illustrate that what existed before the Big Bang could be an entirely different domain, one governed by principles we have yet to understand fully. As we wrap up this journey into the singularity before time, it's fascinating to consider the profound ideas we've explored, how existence might have preceded the Big Bang, the concept of a timeless singularity, and what that means for our understanding of the universe's origins. These questions push the boundaries of our imagination and science, reminding us that the quest for knowledge is endless and deeply personal. First, hope you found this exploration as intriguing as first did, and that it sparks your curiosity to delve even deeper into these cosmic mysteries. If this discussion resonated with you, don't forget to like, share, and subscribe for more dives into the universe's greatest enigmas. Keep an eye out for upcoming content that will explore even more mind-bending ideas about time, existence, and what's beyond the known. The universe is vast, and our journey to understand it has only just begun. Stay with us as we continue to unravel its secrets together.